So we will come back to the last two online speakers. The first one is Fernando Szabados. He's coming from the Energy Observer development. But I will let Fernando to explain all about not only the company, but the Energy Observer for those of you that you don't know what it is. So, Fernando, you the floor. You can share your screen if you want, or you want us to share the slides?
No, I can share it. Can you hear me well? Do you see my screen? Okay, perfect. So thank you very much for having me today. So I'm gonna present you our company and also the products that we have developed, mainly focused for the marine applications. I work for EODev, so it's basically energy observer developments, and our goal is to develop and industrialize sustainable, reliable, and affordable hydrogen-based energy solutions. Just to give you some few details about the origin of the company, we come from the boat. So basically, EODev was created by Energy Observer Group, which has created a totally autonomous vessel, a catamaran that is totally zero emission and has been navigating for more than 45,000 miles. It is still navigating right now in Asia. And basically, it's producing its own hydrogen and using the fuel cell for power, wind turbines, solar panels, and etc. So it's a totally autonomous vessel. And basically, the idea behind creating another filial, Energy Observer Developments, which is the company I work for, was to design and industrialize and commercialize these products. So basically, our goal is to accelerate the energy transition by offering these products to the market to help decarbonizing the activities. So here, basically, you have the two products that we have in the portfolio today. It's important to mention that it's not a prototype or demo units. They are already proven and tested technology that are ready to the market. Some key information about the company. So from EODev, as I said, we have been created by Energy Observer Group in 2019. We are today 60 people. We have already raised 40 million euros. We got 4 patents and a production capacity of 600 units, thanks to our partnership with an area. And we have 3 sites in France. So basically all of our products, they are produced in France for the moment, close to Paris area. So we have some big industry companies as shareholders. So we can mention Accor, Energy Observer Group, Bonheur, Telem Insurance, Toyota, Amphil. And as industrial partner, we also have Toyota, F-System, and Eneria. So basically, all of our fuel cells, they are provided by Toyota. So it's basically the same fuel cell they have in Toyota Mirai cars that we have marinized for this application, for the marine. F-System basically for the power management system and for the batteries. And Eneria, they will be assembling and doing the maintenance of our products here in France and some other countries where they are present. So here you see the picture where our products are currently being produced in Eneria. This is our office and this is our unit close to Lyon. Now to talk about the Rex H2, it's an onboard hydrogen power generator, which has the Toyota fuel cell inside. It's 70 kilowatt fuel cell. Starting the month of May, it's gonna be the next generation of Toyota fuel cells. It's a reliable component because it has been tested and proven, already integrated to the first boat. So the idea behind this presentation is to give you some technical and practical information about some applications. So I'm gonna give you 4 examples during this presentation of already commercial applications where the unit has been integrated. So basically reliable because it has already been integrated to Hynova 40 volt commercial application, also being tested in Energy Observer catamaran, and also being used for mobility in Toyota cars. It's efficient, so I believe we have mentioned it already, but the efficiency of the fuel cell is 50%, which is higher than diesel engines or even combustion engines using hydrogen. So it's a great efficiency. It's a plug-and-play solution. I'll turn off my camera. for some requests. Okay, so it's a plug-and-play solution. So we have tried to develop the easiest way possible to integrate that to the boat and to any kinds of boats. So that's what we did, and it's also modular. So basically, I have said it's a 70 kilowatt full cell starting in the month of May, but it's modular. So basically, if you require 210 kilowatts, you can have 3 of these. You can also stack them by 2 if you wish to decrease, sorry, the footprint. So it's a totally scalable solution. This is the new design. So we have changed a little bit in order to facilitate the integration. So we have added the accessories inside of it. So here you have the details about the interest, the outlet for the water, for the electric power. And also we use the seawater for cooling, which is great. So for external cooling, we're using the seawater. Basically, we only need hydrogen and oxygen, and from this electrical chemical reaction, we got in the outlet 50% of power and 50% of heat and water, which is not drinkable, but for boats it's also great because they can reuse it for toilet, for example. We can use this power for electric engines and also hotel load. So basically, this application it's for propulsion and for hotel load. We can also use that as an emergency genset. So basically, the idea behind that is to replace diesel gensets and also to extend the range. That's why actually we call it REX H2 range extender, to extend the range of electric boats. These are some key technical specifications. I'm not getting to the details of it, but here you see the dimensions, the total weight, you see the power. We use the proton exchange membrane type of fuel cell provided by Toyota. As I said, 80% of components that we use come from Europe and 60% from France. These are some examples and comparison between diesel, electrical, and hydrogen applications. What is important to mention is that there's an interest in hydrogen applications for the marine because of the energy density and also the time that we take to refuel it. So that's why it's, you can see here some times and for the refueling. If you are talking about no emissions, we cannot use diesel. We are talking about electrical, and if we compare both, you see that the time to recharge batteries, it's too long, and also the total weight of the solution is also much heavier than a hydrogen-based solution. And also regarding the pricing of diesel and hydrogen, today it's higher, but the tendency is that it's going to decrease for the next couple of years, and the diesel price is going to increase. So that's the interest about the hydrogen. And also we are seeing this as a range extender, as I said, so to use it with batteries. So a hybrid solution between electric and hydrogen boat. This is Hynova 40 boats. As I mentioned, this is the first commercial application that we had. This boat is exploited in the south of France. It was built last year by Hynova. So it's a pleasure boat, a 12-meter yacht, which has basically 3 batteries, 1 full cell of 60 kilowatt because it was the previous version, and 3 hydrogen tanks of 7.5 kilograms each. Also important to mention that this is not just a demo unit or a proof of concept. It's a really commercial solution, and Hynova is going to have a new boat delivered this year, which is going to be Hynova 42 boat. I'm going to give you some more additional details, but just to mention that this is also commercial, in commercial phase, so this is really happening. So basically some additional information about this boat. As I said, it's 12-meter. It got 2 motors of 184 kilowatts, 1 full cell of 60 kilowatt plus 3 batteries, also very nice, of 44.2 kilowatt hour. Has a maximum wind speed of 22 knots, working speed of 12 knots, and operating speed only using the full cell at 10 knots. The hydrogen pressure storage, basically it's 350 bar. Basically all the applications we have is 350 bar. For the moment we are restricted with regulations at this pressure rate, and also for the refueling solutions that we have today. So all the applications that you're gonna see, I'm gonna show you, it's under 350 bar storage system. This one has 22.5 kilograms of hydrogen, and it weighs 8.5 tons. So this is also important to show you the comparison. If it was a pure electric boat, it would weigh 12 tons. So since this is a hybrid solution between batteries and hydrogen, it weighs only 8.5 tons. So we are gaining 2.5 tons, which impacts also the performance of the boat and the energy consumption. This is the next boat that Hynova is delivering this year. So expected to be launched by September this year. It's going to be a little bit bigger than the other one, but it's still with two motors of 184 kilowatts, two Rex H2 this time. So they're going to have two full cells of 70 kilowatts plus two batteries of 44.2 kilowatt hour. So as I said, same pressure rate, 350 bar, and the quantity of hydrogen is also increased. For these yachts, it's going to be from 30 to 37 kilograms. So basically, they want more power, autonomy, and also a redundant solution. So basically, if there's something going wrong, they can also get back to the port using this quantity and this autonomy. This is the next example that I want to show you. It's Fontaine-Pajot. Actually, Fontaine-Pajot, they have plans by 2050 to reach zero carbon emissions. And they are using our unit for hotel load, basically. So this is the catamaran Samana 59. It's going to have our units. And here I'm going to show you some more details about the application. So basically, it's a cruising catamaran of 18 meter. It's going to be exploited in the Caribbean islands. It's going to use the full cell for hotel load only and propulsion if required. So it's quite flexible. If they want to use it to provide power for propulsion, this is also possible. And they wanted an autonomy of 2 weeks. So basically providing power for whole hotel load during 2 weeks. They needed 2 hydrogen tanks. It's not massive, the quantity of hotel load they need. So basically we're talking about 15 kilograms of hydrogen, and pressure rate same, and estimated integration date by September this year. So this is also, we got the order, it's all good to go. And basically the application is zero emission cruising and propulsion when required for this catamaran. Also important to mention, I spoke about the efficiency, but also we have no noise involved. So since there's no combustion inside of it, there are no moving parts, and it's really quiet solution. So it's a great experience for customer as well, for yachts, for boats, because you can navigate at 10 knots, for example, with no noise and no smell either. So this is a great solution for customer experience as well. Not talking about the environment, of course. So this is another great example of application for Olympic shuttle. We have won a project among 120 applications to provide a shuttle during the Olympic Games in Paris in 2024. This is a partnership between EODev, Toyota, and also Neptec. So basically, this ferry will be able to transport up to 150 passengers, basically using the boat during the day. We estimate reductions in carbon emissions at around 1,100 tons per year and per ship as an average. So this is some additional examples and technical information about this ship. It's going to be exploited in Paris and Marseille, firstly, in 2024. It's going to have 2 full cells of 70 kilowatt each, which basically will be used for hotel load and propulsion. And they will also have 5 batteries of 44.2 kilowatt hour. It's going to be a day usage, so the batteries and the hydrogen they're going to be refueled during the night. It's going to be exploited by around 10 hours per day, and the average speed in Marseille is going to be 18 knots, and in Paris 6 knots. It's going to have from 8 to 11 hydrogen tanks, which can provide from 60 to 8 kilograms of hydrogen stored for the autonomy. Pressure the same, 350, and the estimated launch date is for 2024. So this is also a great example talking about ferries and passengers for the island applications. I believe it's a great example in totally zero emission. Like to finish with the examples, this is a fishing boat. So we have also won the project. So the estimated integration dates for January 2023. The exploitation site is going to be in Corsica, so an island as well. So this is going to be a 12-meter fishing boat with the Rex H2 used for hotel load and propulsion. It's going to have two full cells inside of it, so 140 kilowatts in full cell plus 8 batteries of 44.2 kilowatt hour. It's also going to be a day usage. So batteries and hydrogen refuel are going to be made overnight. They're going to exploit it for around 10 hours per day with a maximum speed of 14 knots. They're going to have 9 hydrogen tanks, which can provide 67.5 kilograms of hydrogen. Basically, that's total quantity of hydrogen. Same hydrogen pressure. And basically, this is going to be to professionalize fishing professionals. So in Corsica. Also important to mention that today we're going international, so we have closed deals with different distributors worldwide. We're open for negotiations in new areas where we find there's a demand, a market demand. We have a huge production capacity, so we are ready also to scale up in production and to provide the units required for bigger projects like 20 units, 10 units, and so on. So here you see the list of countries where we are present today for sales, but also service. This is also important for us. And I thank you very much for your attention. It was quite quick presentation. I tried to stick to the time, but if you have any questions, I'll be more than happy to answer all of them. And you can also find all my contact details if you wish to contact me. Thank you very much.